Okay, so our objective, and for the people coming into me, when we take notes, you just copy what I have, okay? So just everything that you see here, you're going to write down in your notes. You guys should have spirals. Ruby, that may be new to you. We just keep everything in one spot, not a 3-ring binder, because it gets to be too messy and people kind of lose their organization. So if you need, I do have one spiral left. Okay, hold on. Okay, so our objective today is to solve multi-step equations, including parentheses and / or variables on both sides. So this is out of same lesson that we were in from the Green Book, the 3-5. So what I mean by and or is that you may have variables on both sides, or you may just have variables on one side. You may have parentheses on both sides, or you may have parentheses just on one side. So it's going to be a combination of all these things. All right? So what I'm going to do is, in the top of our note, review the same steps we've been talking about, because the steps haven't changed through this whole process. Step 1, we need to see if we can simplify. Okay. Step 2, we're going to do opposite operations to get variables on the left. Step 3, get constants together on the right. Step 4, get the variable alone by doing opposite operations. And then step 5, make sure you write your answer appropriately. Variable equals answer. All right, so we're going to write down that same idea again. We're going to be a little bit more abbreviated because we have it in detail in our prior notes. Okay, so we're going to simplify each side of the equation comma, if necessary. Now, if you only have 2 terms per side and they are not like terms, there's nothing to simplify, so you won't have to do that step, okay? But these are getting more complicated. These are definitely getting more complicated. What are the 2 major things we talked about that we would do in order to simplify a side? What are the 2 things that may show up that we're going to have to deal with prior to us doing opposite operations to get... No. We may have to deal with parentheses, and what helps us get rid of parentheses? It's a property. Most important one in algebra. Distributive property. So we may need to distribute to remove parentheses. So hint, hint, yes, when it comes to math class, you have to memorize some things. And when you are memorizing a process, then you apply that process over and over again. And once you've got that in your head, you don't have to think about, what do I do now? What do I do now? It's always the same thing. That's what a process is. It's repeatable, okay? So that's one thing that may have. So if you have parentheses, we got to get rid of them first and foremost. We can't do math with anything if it's stuck inside of the parentheses. So we use the distributive property to help us do that. Now, what often happens after we distribute, we may have 3 or more terms per side. So then we're going to look for like terms and combine them. And combining means to do the same math on both sides, or that's on the same side. So combine like terms. And this is the same math shown. So you're not doing opposite operations. So if there's a plus and a minus, you're going to subtract them because that's what the rules are for integers. Okay. Same math shown. So we don't do opposite operations when they're on the same side. Same side, same math. All right. So now we should be down to no more than 2 terms per side. And now we're ready to try to get our equation where our answer needs it to be. Okay, so we're going to do opposite operations. What goes on the left? To get variables on the left. And the reason why we do that, because that's the answer format. We're being asked to solve for that variable, so that variable needs to be part of the answer. Also, it helps us get ready for inequalities.
And you can only go left and right.
We want it always to go left because of number one, that's what my answer has to look like. The first thing I'm going to look for in the answer column is the variable on these particular equation problems. Second thing, when we do inequalities, if your variable is not on the left, you're going to have trouble graphing it.
Okay.
So it's just a pattern we like to follow. So variables go on to the left. That's key right there, is variables on the left. Now we're going to do opposite operations. To get constants on the right. And again, that's how our answer needs to be. So constants, those are the values that are numbers with no variables attached to them. So at this stage, best case scenario, your answer's done. Variable equals number. Worst case scenario, we're going to need to do one more set of opposite operations to get the coefficient to go away from the variable. Now, the coefficient is either going to be multiplied or dividing with the variable. Most of the time, what did you guys see in your homework problems? You would have to divide. So originally you would have a number times a variable. So that's what your coefficient would look like. It would be part of a product. So the opposite would be division. It's very rare circumstances when you have to multiply at the very end to get the variable by itself. So we're going to do opposite operations. To get the variable alone. So we want to end up, and this is the one time, most of us don't like being alone, but this is the one time we want something to be alone. We want the variable to be alone. So let's kind of go back and look at a couple things here. So when I was doing variables on the left, my opposite operations were which operations? When I'm taking my variables and making sure they end up on the left side. Add, subtract, multiply, divide. What are they? Okay. That would be adding or subtracting. Those are the only two things that I could possibly do to get the variables to go to the left. I determine which one I'm going to do based on what the sign is of the number I'm trying to move. Okay? If my phone is ringing, it can ring. And then what operations do I do to get constants on the right?
Opposite.
I do opposites, but what are the opposites? It's the same thing, right? Adding or subtracting. Okay? And then what did we say we do with the coefficient? What would be the opposite operations for the coefficient? Division or multiplication. Okay. So, a little different. Now, I have one more thing to add, but I want to make sure that everybody's all on the same page. Last thing is the answer format is the same for all of these because these are given equations and they tell you what variable you're solving for. So your answer format is variable equals answer. So you're going to have some sort of variable, and then it's going to be equal to some number. Let's go ahead and do some practice problems, and the directions are going to ask you to solve. I'm going to throw in the and check. And the reason why we check is I don't want you to find out if you did it right or wrong on a quiz or test after I've graded it. I want you to turn that quiz or test in with confidence that you did it right. And what I'm noticing is that a lot of people are making careless mistakes, and they're not showing me. When they're not checking the work, they're not catching it. And then it just is sad when I see these grades. It's really hard to try to give you guys some partial credit sometimes when the work is not there. So I've got 3 times the quantity n minus 2, that minus 1, equals 2 minus 5 times the quantity n plus 5. So this particular one, I've got parentheses on both sides. So job 1 is to remove those parentheses. And to do that, we're going to distribute. So we're going to multiply 3 times n, which is 3n, and we're going to multiply 3 times negative 2, which is negative 6. And then I write out the rest of the problem. So minus 1 equals 2. Now, for some reason, some of you keep doing 2 take away 5 is negative 3. You cannot do that, because 2 and 5 can't talk to each other because of those parentheses. Now, here's the second piece of problem. You're not distributing a 5, you're distributing a negative 5. So we have to watch out for signs and the 5. So a negative times a positive is a negative. 5 times n is 5n. So I always put my sign in first. A negative times a positive is a negative, and 5 times 5 is 25. Okay? So that's what I get, and now I've distributed. But look what you end up having. You end up having some like terms. So what we're going to do is combine them. So on the left side, the like terms happen to be constants. So we're going to go ahead and do their math. And we get 3n. The signs are the same, so we're going to add, and we get negative 7. Over here, the like terms again happen to be constants. So 2 take away 25. Signs are different. Bigger number is negative. And 25 take away 2 is 23. When the signs are opposite, I'm going to subtract. And then I have the minus 5n. Now I have no more than 2 terms per side, and now I'm ready to take things left and right depending on what I'm getting rid of. And I always, just by habit, I always do my variables first. So the opposite of subtracting 5n is adding 5n. And we get 8n minus 7 equals negative 23. So then I need to go the opposite direction with the constants, and the negative 7, the opposite of that is adding 7. So many details to pay attention to. So many rules that I have to keep straight when I'm just solving some simple problems. So here the signs are different. Bigger number is negative. 23 take away 7. Well, I'm going to rename this. Oops. So 13 take away 7 is 6. 1 take away nothing is 1. So I'm at the stage now where I've got 8n is equal to negative 16. And then I go ahead and the opposite of multiplying by 8, dividing by 8. And now I have a new set of rules. In multiplying or dividing, if the signs are different, you're going to get a negative answer. And then 16 divided by 8 is 2. Okay, now check. It gets a little bit messier the more numbers you have. But again, we're trying to prevent finding out if you got it right or wrong from me grading it. We want you to know. So our question is, are these two halves the same number? So in this parentheses, I've got negative 2 take away 2, which is going to give me a negative 4. And then outside is a negative 1. And over here, negative 2 plus 5, the signs are different, so I'm going to subtract bigger numbers positive, and I get a positive 3. Order of operations says you have to take care of multiplying first, once you've taken care of what's in the grouping symbol. So 3 times negative 4, signs are different, I get a negative, so I get negative 12, and then I write down the negative 1. Here, the 2 has nothing happening to it. The priority is the negative 5 times the positive 3, which is a negative 15. So these two are the same sign, so I add them and I get negative 13. These two have different signs, so I subtract them. Bigger numbers negative, and I get negative 13. Since negative 13 equals negative 13, what that does is verify that the answer is n equals negative 2. Now, some of you might say, wow, that took me so long, I'm not sure I actually want to do that. Again, do you want to make sure you have the answer right or not? And it's a good practice of your skills. All right, so let's go on and let's talk about a different problem. So next problem. We have 4 times the quantity, 3 minus 5, plus 5y. That minus 4 equals 3 plus 2 times the quantity y minus 2. Oops, I missed something, sorry. should be 3 plus 2 times the quantity y minus 2. So what you notice is that we do have parentheses and we do need to deal with them. So we're going to distribute first. And we get 4 times 3 is 12. 4 times 5y is 20y. And then we have the minus 4 we've done nothing with. Here we've got nothing happening to the 3, but what we're going to be doing is distributing this positive 2. So 2 times y is positive 2y, and 2 times negative 2 is negative 4. Now I do have like terms per side, and so I'm going to combine them up. And I've got, again, constants, so 12 take away 4 is going to give me 8. And then I have plus 20y equals, and again, we have constants. 3 take away 4 is a negative 1 plus 2y. And now what we're going to do is opposite operations. And we're going to start with taking the variables to the left. So the opposite of adding 2y would be subtracting 2y from both sides. Always, it's equal quality when I take care of things on both sides. So I have 8, and then bigger number here is positive. 20 take away 2 is 18, so I get plus 18y equals just negative 1, because the 2y's canceled out. Now I'm going to get my constants to the right by doing opposite of 8 is subtracting 8. Signs are the same, so I add, and I get a negative 9. Last step, divide by 18. Now notice what happens. What kind of answer am I going to get on this problem? I'm going to get a fraction. Okay, I don't know why, but I get kids will tell me the answer is negative 2. Okay, what we need to do is simplify. So we're looking for what do those two have in common. We're going to divide a 9 from each of them. So negative 9 divided by 9 is negative 1. 18 divided by 9 is 2. My answer is y equals negative 1/2. Now, here's what I'm going to suggest that you avoid dealing with. Don't go to decimals. If you get a repeating decimal, then, and I've seen this even in the algebra class, they change everything to decimals, and then they get repeating decimals, and you can't actually add repeating decimals together. Okay? All right. You better wake up, Samantha, because we got a biggie coming up next. Kim.
Why did the first one become a fraction?
The answer to number 1?
Yeah.
Okay, well, let's look. Because I had a bigger number being divided by a smaller number. Okay, so that's going to give me a larger number. Now, it could be an improper fraction. That's a possibility. But in that case, 8 went evenly into 16, so that's why I didn't get a fraction left over. But on this one, the denominator was definitely larger, so that means I am going to get a fraction for sure. Okay. All right, let's do one with fractions. Negative 1/2 times the quantity 8y plus 4, that minus 17, equals 1/4 times the quantity 4y minus 8. So what I've been noticing is that when we were dealing with dilations and your dilation factor or scale factor was a fraction, you guys got really confused how to deal with that. So we're going to review multiplying with fractions again. So what we're going to do is distribute. And when we're distributing the negative 1/2, we're going to multiply it by 8y. So if it makes it easier, take that whole term and write it over 1. That way you can see numerator compared to denominator. And then we've got, on the next one, we have plus here, and we've got negative 1/2 times 4, which we can write as 4 over 1. And then we have minus 17. And then over on this side, I'm going to use a different color. We're going to have 1/4 times 4y. And then it says minus. And then 1/4 times 8. So one of the things we try to do when we're multiplying is normally we would just multiply straight across, but it's smart to try to simplify each side or each of the fractions if you can. So if there's something that a numerator and a denominator have in common, that's what we want to cancel out. So if you notice in this first grouping, the -1/2 times 8y over 1, in this denominator there's a 2, so if I divide out a 2 I'm left with a 1. This I have an 8, and 2 goes into 8 4 times. Here, 2 goes into itself once and into 4 twice. Here, 4 goes into itself once and into itself once. Here, 4 goes into itself once and into 8 twice. Now, we see what we have left over. I have a negative times a 4 times a y. If I just have 1s in the denominator, I don't include it, so I just have -4y. Over here, I have a -1 times a 2, so I just get a -2. And then there's still the -17. Okay, Taylor, you're not writing stuff down. You need to write this down. We have 1 times y is y, minus 1 times 2 is 2. So notice, since all of my denominators are 1, I did not include them in my answer. I don't need to. So now I look on the left side, and sure enough, I do have some like terms. And it's the constants. So I have -4y minus 19 equals y minus 2. And now I can start doing opposite operations. To get the y's on the left, the opposite would be subtracting y from both sides. That gives me signs the same, so I add and I get -5y minus 19 equals -2. And now I'm going to get the constants to the right, doing opposite operations. Opposite of subtracting 19 is adding 19. So I get -5y equals, now here the signs are different, so I'm going to subtract bigger number is positive. 19 take away 2 is 17. Last step is to divide both sides by -5. And notice, I get a fraction on the right side. 5 doesn't go into 17, and there's nothing to simplify by. So all I do is say my answer is negative. I just bring the negative up to the numerator, is -17/5. And that's how I conclude that answer. Okay?